Solving reciprocal equations. What are these reciprocal equations? An equation is said to be reciprocal if the quotient of the terms equidistant from the first and last are equal. Let us consider some equations. Say f of x is equal to an x power n plus so on till a naught equal to 0. In this, an is the first quotient and a naught is the last one. So these two are equidistant. They have to be equal. In similar manner, an minus 1 is the second term from first or starting of the equation and a1 is the second term from the ending of the equation. So these two have to be equal. Now if we write it down, it would be like this: an equal to a naught, an minus 1 equal to a1, an minus 2 is equal to a2 and so on. Here we are considering mod because an equation can have either positive quotients or negative quotients. We are just considering the value here. So mod is taken. Now let us look into this example. 6 is the quotient from the starting and even at the last term we have 6. These two are equal. Then we have minus 35, minus 35. Both are second terms and they are equidistant. And the middle term is 62. Now here we can see the quotients which are equidistant from first and last are equal. So this is a reciprocal equation. There are certain properties of reciprocal equation. For a reciprocal equation, if alpha is a root, then even 1 by alpha will be a root. Root means when we substitute x with this particular value alpha, then f of alpha will be equal to 0. Means, say there is an equation for which f of 2 becomes 0. Then even f of 1 by 2 for that particular reciprocal equation will be 0. Then 0 cannot be a root or solution for a reciprocal equation. If x in the reciprocal equation is substituted by 1 by x and further simplified to make it as a polynomial, then the resultant polynomial will also be a reciprocal equation. Consider the equation we have taken earlier, that is f of x. In this, if we substitute 1 by x, the equation will get modified like this. Here, x is in denominator, which means 1 by x power n is nothing but x power minus n. But in a polynomial, we cannot have negative degrees. So, the entire equation has to be multiplied by x power n to make it as a polynomial. Multiply this equation with x power n, then each and every term will get multiplied with x power n. For the first one, these two will get cancelled, numerator and denominator are same. For the second term, when we multiply with x power n, here we will apply law of exponents in which we have a power m upon a power p is equal to a power m minus p. Using this, we have to simplify the terms, that is x power n minus degree in denominator is n minus 1. So we'll use that. This is x power n, minus of minus is plus 1. So n cancel. This leaves x power 1 as the resultant. So for second one, it will become into x power 1. And for the next term, it is into x square. Here it will become x power n minus 2. Then on multiplying with x power n, it is x power n minus 1. And for the last one, x power n. Like this, the equation will get modified. We'll look into that modified equation here. So this is the equation after multiplying with x power n. But from the definition, we know that first quotient an will be equal to a naught. Second quotient an minus 1 is equal to a1. A similar way, an minus 2 is equal to a2. So we'll substitute these values here. So an will be equal to a naught. And then this will be equal to a1x less a2x squared. In similar way, here we have an minus 1 into x power n minus 1 plus an x power n after substituting those values. Now, if we look into this, it is same as the original equation we have taken. After simplification, we have got back the original equation f of x. f of x is equal to x power n into f of 1 by x. Such a reciprocal equation is called as type 1 reciprocal equation. The quotients here that are equidistant should be of same sign. Means a and a naught would be of same sign. An minus 1 and a1 would be of same sign. In similar way, equidistant coefficients should be of same sign. A and a naught. The coefficients which are equidistant, they have opposite signs. Even an minus 1, a1, both are equidistant. That second terms from starting and ending of the equation, they have opposite signs. This is the second case in reciprocal equations. Till now, we have seen a case where the coefficients that are equidistant have got same sign. But here, now in this particular case, we have equidistant coefficients with opposite sign. In this case also, when we replace x with 1 by x, we'll see what will happen. Now, when we do 1 by x, the equation will get modified like this. Again, to make it as a polynomial, multiply with x power n. After multiplication with x power n, this is the resultant equation. Now, we know that an and a naught values have to be same. So, in place of an, we can write a naught because those two values are same. Let us write this here. So, a naught minus, this has to be a1, only considering the value, plus a2x square, and so on. Here we'll have an minus 1, x power n minus 1, minus a naught value and an values are same, is equal to 0. When we try to compare this with the original equation, here we can see that the original equation has got an, but here we have minus an. So what we can do is just take minus common from this equation so that it will resemble the original equation. On taking minus as common, we'll have this equation. So from the starting, this is a naught, which means it is positive. Less is nothing but minus into minus. So we have taken minus common. So it's minus a naught. Here when we take minus out, we'll get positive. But plus it will become negative. Like this, the signs will change. So it is plus a and minus 1. It will become minus. Get the minus, then it will become plus when we take minus common. Like this, the signs of quotients will change. So now this can be compared with the original equation written as equal to minus f of x. Here we have got f of x is equal to minus of x power n into f of 1 by x. We have taken the negative sign to the other side. This would be a type 2 reciprocal equation. You can write it like an is equal to minus a naught, an minus 1 equal to minus a1. It just means to say that they have to be of opposite sides. How to solve these reciprocal equations? Any equation can have either an even or odd degree. So we'll see for both the degrees here. For an odd degree reciprocal equation of type 1, x is equal to minus 1. If we keep in that, it will become 0. Which means that x plus 1 is a factor of that particular equation. And in case if it is of odd degree and type 2, then x is equal to 1. On substituting this value, we'll get f of 1 equal to 0 or x minus 1 is a factor. In case of an even degree and of type 2, both x is equal to 1 and x equal to minus 1 will satisfy the equation if the middle term is 0. Now let's see how to solve an even degree reciprocal equation of type 1. Only 3 cases on doing factorization with the mentioned values, the resultant would be a even degree reciprocal equation of type 1. First, we will try to see how to solve that even degree type 1. Consider this is of type 1 as the equidistant quotients are of same value and with same sign. So 6 here and 6 here, minus 35, minus 35, and the middle term is 62. First step would be to arrange the polynomial in such a way that parts are in descending order. After doing this arrangement, consider the first term. Here the variable has got 4 as the part. We have to take the exact half of it, that is x square. Now with this x square, we are going to divide the entire equation, and that makes 6x square minus 35x plus 62 minus 35 upon x plus 6 upon x square equal to 0. Now rearrange the terms in such a way that wherever we have variable with the same part, we will write them together. Say 6x square plus 6 upon x square minus 35x minus 35 upon x plus 62 equal to 0. Now we'll take 6 as common here. When we take 6 as common, it will be like 6 of x square plus 1 upon x square minus 35 from here, that makes x, and from here it will become 1 by x plus 62 is equal to 0. Now in place of x plus 1 by x, we will substitute with k. On squaring both sides, it will become x square plus 1 upon x square plus 2 is equal to k. Take 2 to the other side. This leaves x square plus 1 upon x square is equal to k square. This square, k square minus 2. Substitute this x plus 1 upon x and x square plus 1 upon x in the equation. This is 6 of, in place of this, we have k square minus 2 minus 35. In place of this, we'll keep k plus 62 equal to 0. Now simplify this. 6k square, 6 into minus 2 is minus 12, minus 35k plus 62 is equal to 0. 6k square, this minus 35k. Now we have minus 12 plus 62, it gives plus 50 equal to 0. This particular equation we have to again factorize. Now we are left with 6x square minus 35k plus 50 is equal to 0. 6 into 50 is 300. So the middle term has to be written in such a way that it gives 300 as the result. So this can be written as 15 into 20, that is 300, and 15 plus 20 is 35. So 6k squared minus 15k minus 20k plus 50 is equal to 0. From these two, we'll take 3k as common, that leaves 2k minus 5. From these two, we'll take 10 as common, and it is 2k minus 5 is equal to 0. Now take 2k minus 5 from these two terms out. That leaves 3k minus 10 equal to 0. And when we make this equal to 0, k will become 5 by 2, and for this, k will become 10 by 3. But k is nothing but what? X plus 1 by x is equal to 5 by 2. Now again solve this. Cross, here we take x as common and then cross multiply. So x square plus 1 into 2 is equal to 5x. 2 into 2 is 4. So 4 can be written as 4 into 1. So 4 plus 1 is 5. We can consider that 2x square minus 4x minus x plus 2 equal to 0. Take 2x common. So x minus 2. Here we'll take minus 1 common. X minus 2 equal to 0. Now we'll have x minus 2 as common. Then 2x minus 1 equal to 0. When we equate this to 0, it gives x is equal to 2. On equating this to 0, it will give x is equal to 1 upon 2. So that's when we have taken k is equal to 5 by 2. When we take k is equal to 10 by 3, x plus 1 upon x is equal to 10 upon 3. Again take LCM and do cross multiplication. That gives 3 into x square plus 1 is equal to 10x. Now take 10x to the other side. 3x square minus 10x plus 3 equal to 0. 3 into 3 is 9. 9 can be written as 9 into 1. 9 plus 1 is middle term 10. Then we will write it as 3x squared minus 9x minus x less 3 equal to 0. Take 3x common here. That leaves x minus 3. Take 1 common here, minus 1. That is x minus 3 equal to 0. Now we'll take x minus 3 as common. That leaves x minus 3 into 3x minus 1 equal to 0. When we equate this to 0, this leaves x is equal to 3. On equating this to 0, we'll get x equal to 1 upon 3. Now x is equal to 2 and x is equal to 1 upon 2. X is equal to 3 and 1 upon 3 are the solutions for the given equation. As the equation is of degree 4, it will have 4 solutions. Now we have got the solutions. If we observe this particular equation and its solutions, we have these solutions. Solutions are roots of the polynomial. Recollect the point we have seen in earlier case. When we have alpha as a root, even 1 by alpha will be root. That we can observe here. This is alpha, then 1 by alpha. If 3 is alpha, 1 by 3 is 1 upon alpha. So the reciprocal of the root will also be satisfying the equation. Now we know how to solve a even reciprocal equation of type 1. We'll see how to solve the remaining cases that we have discussed in the earlier slide. We'll take one example and see how to proceed in such cases. Now consider this. This is of degree 5, which is an odd number. For degree 5, and what type of equation it is? The first thing is 6 and here it is minus 6. So opposite sign, minus 41, 41. Again opposite sign, 97, minus 97. Opposite sign. So all the equidistant coefficients are of opposite side. So every pair of equidistant should follow this opposite sign thing. Then only it would be of type 2. Now for type 2 and odd degree, we have seen that x is equal to 1 will satisfy the equation. We'll check it now. When we keep 1, it will become 6 minus 41 less 97 minus 97 plus 41 minus 6. Now 6, 6, 41, 41, 97, 97, it is equal to 0, which means x is equal to 1 is satisfying. In that case, what will happen? X minus 1 will become the factor. So when we know one factor, first we will try to divide the polynomial with that particular factor. Is this entire polynomial? We will try to divide this with x minus 1. When x is equal to 1 is satisfying, then x minus 1 will become the factor. X minus 1, how to do this factorization? We just have to follow the division method. Take the first term here, 6x power 5 upon x. If we do that, it will give 6x power 4. So multiply 6x power 4 with this. This is 6x power 5. Minus 1 into this will give minus 6x power 4. This is power 4 and this is power 3. Now on subtracting, the signs will change. This leaves minus 35x power 4. Get the next term down. It is 97x cubed. Now we'll divide this minus 35x power 4 with x. That gives minus 35x cubed. So this is power 4. Minus into minus is plus 35x cubed. On subtracting, the signs will change. This will give 62x cubed. Get the next term down. This is 97x squared. Now it will be 62x squared times become 62x cubed minus 62x squared. Again the signs will change. This is minus 35x squared. Next term down. This will be like minus 35x. Follow the same process. plus 35x. Again change the signs. Now 41 minus 35, these two will get cancelled. 41 minus 35 is 6x minus 6. This is 6 times. Again 6 minus 6, we will get 0. While doing subtraction, we'll change the sums and if it is 0. As x minus 1 is a factor, it will leave a remainder of 0. Now we know two factors. One is x minus 1 and the second thing is this. So again, this has to be factorized. If we observe this, this is of even power, and even the terms here, the terms that are equidistant now are of same sign, which is similar to the case we have just discussed. So from type 2, after doing the factorization, we got type 1 even degree polynomial, and we know how to solve this. This is the same as the one we have seen now, the previous one. See, this is the previous one we have seen. 6x power 4 minus 35x cube plus 6x squared minus. So same one, then the roots are 2, 1 upon 2, 3, 1 upon 3. These are 4 roots, and here we have x is equal to 1 is another root. As the degree here is 5, we have put all the 5 roots here. In this way, we can solve the reciprocal equations. In this video, we have seen what reciprocal equations are and the different properties, like if alpha is a root, 1 upon alpha will also be a root, 0 will not satisfy a reciprocal equation, and whenever we substitute x with 1 upon x and simplify that, we will get the original equation back. Those are the three properties we have seen, and the types like type 1 and type 2. In type 1, we will have equidistant questions of same sign. In type 2 will have equidistant questions with opposite sign, and the possible roots depending upon the type of equation and degree of the equation. For odd degree with type 1, x equal to minus 1 will satisfy. For odd degree with type 2, x is equal to 1 will satisfy the equation. For even degree with type 2, x is equal to 1 and x is equal to minus 1, both will satisfy the equation, and we know how to solve even degree type 1 equation that will help to solve all the reciprocal equations. And with examples, we have seen how to solve the equations.